Let's get started. Hey guys, good evening. Thanks for joining in. So today we'll be going about building how to build a customer prediction model. So customer prediction. Okay, let's. I'll just give an intro of myself. So I'm a grad student in computer science, and I started at Spring this spring. And previous to that, I used to work at Nokia as a software developer in Bangalore, and then I worked for a couple of data science startups, and currently I work as a data science a research aide at Press. So let me just quickly share my screen and get started. Okay, so here's the Kaggle website that I just put a link in the chat. So it's basically open source data science community where it's like different data sets. There's communities, you build models, you collaborate with other people. So it's just like how lead code is for software development. So here's a brief intro of what our problem is. So what's the context? The context is to predict behavior to retain customers. So most of the companies which uses a subscription model or has a product. So almost every companies which has customers needs a retention model because retaining customers is easier than getting new customers. So every company would build strategies around how to retain target customers based on their activities and demographics. So let me just give you a quick view of how the data is. So okay, the data consists of around 7,000 rows, and here is a quick view of the columns. It consists of gender, senior citizen, whether the customer is a senior citizen, partner, dependents, their various features. I'll also go through all of them just in a bit. So this is how the competition page looks like. And then, so everyone can just post their notebooks and make it public so that, other guys can go through it and learn. That's how the Kaggle forum works. So I've just built a notebook, a Jupyter notebook on this forum. And then I also shared a link if you also want to go through it parallelly. So, okay, let's get started. So for those who have not are not familiar with pandas or Python much, so there's no need to worry. You can understand how data science or building a model works. So we'll go through a couple of process, uh, which is like understanding data cleaning and analysis. Then we will visualize it, and then we'll model it, and then in the end we will create reports or analyze how the model did. So even if you don't understand the syntax, it's fine. Just keep just understand why each step is done, and you can just interrupt me whenever you have any questions. I would be happy to answer. So the first step is just to import the CSV file, the data, and once we have imported the data, let's just again have a quick look of how the data looks like. So it has a customer ID column which is unique for every customer, and then it's a telecom data. So basically, there are customers who subscribe to various services like phone service, internet service, online backup. So these are various products or various services provided by the company, and then they just have the data of whether the customer has subscribed to each one of it or not. And then there is, in the end, you can see here there's monthly charges, total charges, and the churn. This is the target column which we will be predicting. So a no means the customer didn't churn out, in the sense customer is using their subscription, and a yes here means customer left out their service or stopped using their subscription. Okay, so if anyone has any questions about the data, you can ask me anytime. And okay, let's get to know the size of data. So the size of data, the first thing which I do is like, just do a data frame dot head and get to know how the data looks. and then get to know the scale of data. So here we have 7,043 customers and we have 21 features. The second thing I have done here is just to check if we have any null values. Luckily, we don't here, but in real world, we'll get a lot of null values and we'll have to use techniques like imputation and all. But this is just a basic data set to get started. So this doesn't have null values, but we'll still have some processing to do, which we'll just go through. So the next thing is just find unique values in each column. So the number of unique values, the customer ID obviously is unique for every customer. So it has around 7K unique values. The gender is just male or female, it's Boolean. So by doing this, you just get an idea whether like what is the data type of the feature. Suppose, let me just go back to the data. So you have gender. Gender is Boolean because it can just take two values. And then you also have some of the features like total charges, which is like an integer or float. It's a continuous variable. So generally in pandas or when you're dealing with data, you have different data types like categorical, which is like how many categories do you have? Something like, as I said, gender. So it has just two categories. And some of the variables are like numerical, like total charges, monthly charges. So you may need to handle the data differently based on what its data type is. So so based on this, you can figure out what the data type is. So you can see your monthly charges and total charges have a lot of unique values. So they're mostly numerical, right? And there are other bunch of other values which doesn't have much unique values, or so they are basically categorical. The one thing you can look here is uh, features like multiple lines have three unique values. So when you look at the data here, multiple lines, it says there's no phone service, there's another value called as no, and there's another which is yes. But if you just see here clearly, no phone service and no actually means the same. So you actually don't need three unique values. You can replace no phone service with just no. So similarly, there would be similar, we would replace these kind of values with a no or yes, depending on how it looks. So, okay, I have just printed it out, the unique values in each column. So as you can see here, unique values in online security. It says there's a no, there's a yes, and there's no internet service. So you can just replace this no internet service into no. So that would convert, this feature into a boolean. Right now it has three unique values. So generally there's a lot of data cleaning and processing before we build a model. So these are just cleaning the data so that we have a good quality data for our model. So this is the step where I just replace no phone service with no. So now if I just plot or just print out the unique values in multiple lines feature, it just says no or yes. So similarly, we can replace the no internet service value with just no in these columns. Online security, online backup, and so on. So you can have a look here. So on streaming movies, for example, has no yes and no internet service. So we just replace all of them with a no. So now all these features that we listed here are Boolean. The next thing I'll do is just print out the data type of each of the column so that you're handling it correct. So object type is nothing but you can just think it of as a string type. So customer ID, senior citizen, which is just a zero or one, it's integer, and then gender, it's a string, so it's an object. But if you look closely, Monthly charges seems fine, which is float, but total charges here it says it's an object. But as we saw here at the beginning, total charges is just the price, so it's a continuous variable. It's should be either int or float. So we need to change that. So the next step would be to change the total charges to assignment float. But but wait, we got an error. So it says here could not convert string to float. So there seems to be a problem. So these kind of problems will occur a lot while you're doing data cleaning because there is always null values or some different values which always cause problems. So you need to always dive deeper when you face such a problem. So once I had found that, I had to go a bit deeper and find out if it didn't have a null string. Generally, uh, columns would have null values like nan, which is in like when you're dealing it in data science with Python, you'll generally have nan, which stands for null, or whenever you're dealing with strings, it would have null strings. So when I plot null strings here, like when I just check if there are null strings in total charges column, I just found a bunch of values which says, let me just pull out total charges. So here's the total charges column, it's just null. So this was the problem. This was the issue which was causing this problem. So could not convert. So now we need to fix it. Anyways, if you guys feel I'm going too fast or have any questions, please feel free to unmute and ask questions. So the total charges column is null and let's fix that. So what we do here is replace the null values with nan, which is like the standard data type for saying that the value is null. And then what we do is we remove those values and then we convert those values to float. So now there are no null values in our data, and then this time we won't get an error. So total number of null values were 11 and we just removed them. The next thing we do here, this is all feature engineering and processing. So the next thing here is we're processing the column tenure. So tenure is basically how many months it has been since the customer started using their service. So just have a look at the tenure feature. So here it is. So basically 1 year means a month. This is 34 months. So what I am doing here is just, creating bins. Like if a customer uh, was subscribed for like 1 to 5 months, I'm just grouping them, and we're creating just groups of five, five or six groups, and making this feature into categories. So we'll have a look here. So, okay. So we are creating 5 bins here. So each bin would have a group of values based on how many months a customer spent. So what we do is we put the top 20% customers who stayed longer into bin one, the next 20% into bin two, and similarly we just cover all the customers. So after we do this, let's just see how the data looks. So if you have a look at the tenure column, it would have, it's now categorical. From numerical, we just created 5 categories, and based on how many months a customer spent, we just put him in the right bin. Okay, now let's just have a visualization of our data so that we just understand it better. Okay, so this is our data. As you can see, almost 73% of the customers did not churn. I mean, they kept using the service, and as you can see here, 26%, almost 26% of the customers did churn. So once we plot this, we get to know that the data set is imbalanced in the sense that there are more customers who stayed than who churned out. So we'll just need this when we build model because you need to handle data sets which are imbalanced in a different way. If it was like 50% for one class and 50% for the other, you can just build the models in a normal way. But just keep this in mind and we'll get back to this when we build the model. Okay, so we'll have, so once I created a pie chart for this, so you can create functions so that you don't have to, do it for every feature. So if I just created a function called as plot pie, and then I just do plot pie, and then I just call the feature name. So I want to see how senior citizen feature looks like. So let's just have a look. Okay. So you can see here in the churn column, almost 25% of the customers who churned were senior citizens. And this is the not churn. The pie chart on the right side is the not churn. So only 13% of the customers in the non-churn group were senior citizens. So you just get an idea of how each feature impacts a customer churn. So as you can see, if he is a senior citizen, you can see that he churns out more, he or she. So let's see how gender varies. And you can see, as if you consider just gender as a univariate feature and not relate it with any other features that we have, it almost seems pretty neutral, doesn't kind of impact. But what generally happens is the model doesn't just look at one feature at a time, it looks at a bunch of features. So maybe gender as a single feature is not predictive, but gender along with senior citizen might be more predictive. We just don't know. So we'll also have a look at how each feature contributes to, prediction, churn prediction in the end by plotting a graph. So you know how every feature is important. We'll plot it. So we can also plot this one. So partner here means whether the customer has a partner or not. So you can see the differences here. So among the churn customers, you see there's a 36% of them had partners. And then who didn't churn? The customers who didn't churn, out of it, 47% had partners. So you can just do it for every feature and just showing it for few of the features, and then you can just play around, and that's how you analyze the data. So there are some more features, and okay, and then here's a scatter plot. So here you'll get to know I've just plotted monthly charges on the x-axis and total charges on the y-axis. Okay, so the one orange dots that you can see here are the customers who churned out. So you can clearly see in this graph that customers who had monthly charges higher, which is in the range of 80 to 100, are churning out more. The customers who had lower monthly charges or lower total charges, which is on the left side of the graph, is mostly blue, which is like not churned. So that is pretty intuitive. So we are just, you know, making sure that our data looks good and it it matches our intuition, or like we get to know the data better. So once we visualize the data and get to know the data better, we can just process it for the model. We need to, so the model does not understand features like yes or no because it does not understand strings. Everything needs to be converted to numbers because that's what the model understands. So we are going to convert all the features into numerical ones based on, and we'll handle it differently based on if it's categorical, like partner is just yes or no, it's binary. So we'll handle this differently when compared it to numerical columns, which is like monthly charges or total charges. So once we analyze the data, we can drop the customer ID column because it's not at all predictive. The one you see here doesn't help us in, you know, prediction because it's just random. Okay, so once we drop the customer ID column, let's just segregate the kind of columns that you have. So I have here like binary columns which have unique values equals to 2. So if number of unique values is 2, I will put it into the binary columns. And what are categorical columns? Even binaries are categorical columns, but it's just has two unique values. But other than that, if it is less than six, this is not a standard. I've just taken it according to this data set. So any feature which has less than six unique values, and if it's not a binary, I'm just putting it into categorical columns. And then our target column, the one which will be predicting whether the customer churns or not. So that one is target column. And then we have numerical columns. So I'm just printing it out here and we can just verify if every feature went into the right, columns. So in the binary columns, we have gender, senior citizen, etc. So looks good. Even churn, which is the target column, has only two unique values. So we have a bunch of categorical columns and then we have monthly charges and total charges into numerical. So this looks good. Okay. So now is we'll encode this data. So basically all these columns that we have here like binary and categorical, we're gonna use a label encoder. So what label encoder does is basically, suppose if you have a gender feature, so it can just assign 0 to male and 1 to female. Or if you have three unique values, it can just assign 1, 2, or 3. So something like that. So once we use numerical label encoder for the binary values, and we also use pd dot get dummies. So I'll just explain that in a bit. And then we scale the numerical values. So scaling is just, like if the values are like 1 to 500, we are just mapping it down to a smaller values like 1 to 5. We are just scaling them down. So uh, some of the models like logistic regression, SVM, they perform better when the numerical columns are scaled. So let's go ahead and do that. Let me just show you the data frame, how it looks like so that you know how they have been transformed. So I'll just do a df.head. So right now you can see monthly charges, it has been, processed, it has been scaled. So it is scaled based on mean and standard deviation. So minus here means that it is, less than the mean. So it basically balances the data. So actually negative doesn't here mean that the value was actually negative. It's just that after processing, it became negative because it is less than the mean or something like that. You can just think of it like that. And now you see all the columns are into like just zeros or ones. Let's just verify if there are no strings or something like that. So this looks good. So pd.getDummy is what it does is, suppose we uh, we just saw that the tenure feature, we split it up into, like five values: tenure 1, 2, 3, 4, 5. So when we do pd.getDummies, it just does one hot encoding. So if the value was tenure 2, it will it will put a 1 in this row. So you can see for the first row, the tenure bin underscore tenure 1 has a value 1 here. So it means that, and the rest all would be 0. So in these five columns that you see here, only one of them would be 1 and the rest would be 0. This is basically called as one hot encoding. And let's just plot the correlation plot. I'll just explain what's the significance. Let me just minimize this a little bit. Okay. like I missed some row. Let me just refresh and run it once again. Okay, let me just quickly run through that. Looks like there's some problem with the variables. Let me just refresh again. So start my session. I think it update refresh now, so all the variables are flushed out. So we'll just run it again. I think I just missed some cell in between, so I'm not sure which one. So I'm just running it again. Okay, now it seems fine. So now we have the PC. Now we did the correlation plot. This is just to check how each variable correlates with the other. It's just a good way to understand different variables. So on the right side you can see the scale here from 0 to 1. So correlation, it means that positively correlated means if one variable increases and if other variable also increases, we say that it's positively correlated. If variable A increases and B decreases, we say that it's negatively correlated. So we can have a look at monthly charges and total charges. We know that they would be correlated, right? If the monthly charges are high, the total charges would also be high. So let's see if they are correlated. So you can see monthly charges here, and then this is the total charges column. So it's this cell where, so you can see that they're almost correlated. If you just, this is green in color, which is like almost a zero point 0.6 to zero point 0.8 correlation. So this is just a good way to know how each variable relates with respect to another. So once we are done through that, let's just build the model. Also, one more advantage of this is you can see the churn column here, and you see that, so the a perfect yellow means a correlation of 1. So with this graph, you can just quickly make sure that in this row there is no other yellow which is other than churn. So this is churn. So churn perfectly correlates with churn. So there's no other yellow value, which means that there is nothing, we are not having anything, any other feature which exactly correlates with churn. Then otherwise, then there's gonna be data leak. So let's just go through our model. Anyways, let me just, okay, we are good on time. Let's just start building our models. I'll just import a couple of packages or models like logistic regression, and I'm going to be talking about confusion matrix and all of that in a while. Precision, recall, these are all required for evaluation of the model. So, okay, so here I'll do is I'll put the churn into the target column, which is the one which we are going to predict, and then there is a train column. So all the other features other than churn are gonna be in our train data set. Once you're done through that, let's just split the data into train and test. So I'm just keeping 15% for the test and the rest 85 for the train. So again, some utility functions. Okay, so now here is logistic regression. So this is just parameter tuning. So I'm just having a bunch of values because I don't know which one performs better. So I just have a bunch of values and we'll see which one does better. So okay, let me just quickly go through some concepts like precision and recall. So the first thing would be, why do we need precision and recall to evaluate our models? Why not accuracy? So suppose you are having a cancer prediction model and there are 100 patients in it. So suppose 99 of the patients does not have cancer and just one patient has cancer. So if we use accuracy in this model, so if there is a model which just predicts that every patient, none of the patient has cancer, so its accuracy would still be 99% because 99 patients do not have cancer. So in this case, you can just see that accuracy is 99%, but do you think such a model would be useful? Like every time, no matter what the features are, we just predict that the patient does not have cancer. So do you guys think that such a model would be useful for us? You can just unmute yourself and then just say yes or no.
No.
Okay, that's actually right. Because the first reason, like we are building a model, is to identify, cancer patients. If every model just predicts that none of the patients have cancer, I mean, it's just useless, right? But it still has an accuracy of 99%. So in some of the cases like this, where the data set is imbalanced, right? Like in the case of cancer prediction, so number of patients who have cancer would be far less than number of patients who have cancer. So you just have to handle that thing and evaluate model in a different context altogether. So okay, so I'll just introduce you guys to the concept of precision and recall. So the graph you see on the right, let me just make it full screen. So the graph you see on the right here, the y-axis is like the ground truth, it's like the actual values, and the one you see horizontal, it's like what did the model predict. So let's first look at true positive. So what does true positive mean? It means that actually the customer did churn and the model predicted it correctly. So it is true positive. So a positive class in this case is churning. And let's just have a look at true negative. What does that mean? It means that the model predicted that the customer would not churn and actually the customer did not churn. So it's true negative. What's false positive? So false positive is our model predicted that the customer would churn, but actually he did not churn. There's one more here which is false negative. It means that the model predicted here NC, which is not churn. The model predicted the customer would not churn, but if you see the y-axis, it's like actually the customer did churn. So I'll just explain it with an example so that it's clear. So suppose we have a data set of 10 values here. So the green ones are the positive values and the red ones are negative values. So we are predicting positive values. So we give a data set to a classifier and then it predicts, it just puts one data point into, the positive class and the rest all to the negative class. So the one you see this table here, this one is called a confusion matrix. So you see the the prediction was positive and the actual was positive. So that is only one point because the model predicted it wrong. So the green points are positive, but the model predicted it wrong. So and How many of them did the model predict positive, but they were actually negative in real? So there are no red points in this bucket, so it's zero. Let's now look at the model predicted it negative, but actually it was positive. So there are eight such values. So all the green labels that you see here, they were wrongly classified by the classifier. So it's eight here. And then the model predicted it as negative, and the actual value was also negative. So that is one, which is the red one here. So it was classified correctly. So what is precision? Precision is out of the values that you see in the right bucket, how many of that were actually correct. So the model just predicted one value and that value was correct, right? It's actually positive label and the model predict correctly. So the precision you see here is 100%. What is recall? So recall is basically how many positive values are there. There are actually nine positive values, but how many of them did the model put it in the right bucket? So only one of them was put it in the right bucket and the rest were, put it in the wrong bucket. So the recall would be 1 by 9, which is 11%. So both of these are important, the precision and recall here, because suppose just consider this as a cancer prediction data set. You don't want any patient to be wrongly predicted negative when he is positive. So you don't want any of these green points here to be put as into negative. Like that's very risky. That's not at all a good model. You can so all the green points, if they're put into the right bucket, then recall would be 100%. It just means that all of the positive points were put into the right bucket. So let's have a look at one more example, which is like here we have nine negative data points and one positive data point. So here you see in the right bucket this time the classifier put three values in the right bucket. So what's the precision? So the model identified 2 points wrongly and only one of them was correct. So precision is it identified one green point correctly, so it's 1 by 3, which is 33%. But recall is 100% here. Why? Because there was only one green point and it put that into right bucket. So recall is 100%. So based on context, we can like sometimes precision is more important than recall. Sometimes recall is more important than precision. So and then using precision and recall, we can calculate F1 score. So this is just a brief idea of precision and recall and the reason why we use it in this data set because it is imbalanced. Okay, so let's go back to logistic regression. Okay, here it is. So let's run it once again. Okay, now we see for the not churn class for the customers who did not churn, the precision was 0.84 good. For the churn, it was 0.71. And we have recalls for both the classes. So recall for customers who churn 0.51. It means that 51% of the customers who churned were identified by the model. So we can just analyze the model based on these statistics. And then there is F1 score, which is the harmonic mean of precision and recall. So F1 score for not churn was 0.88, for churn it was 0.59. Let's just see if we can improve these metrics. So next up we will use a weighted XG boost. So I'm just gonna tell what weighted XG boost is. So we know that the data is imbalanced. So what happens is when we train the model, so every data point would have equal weight, or it will modify the model in the same fashion. But right now, the number of customers who churn are less than number of customers who did not churn. So what we do is we find out a weight for the customers who churn. So the weight here is 2.76. So for every customer who did churn, it would have 2.76 times more weight than a customer who did not churn. Because if we just look at the graph in the beginning, the pie graph, you see that 73% of the customers did not churn and 26% churn. So the value that you see 2.46, it's just 73 divided by 26. So we are just increasing the weight of this orange column so that the blue and the orange column has an equal say in modifying the model or building the model. So that's what is weighted XGBoost. So we just found out that the value is 2.76. So and now we'll build the model. So these are just hyperparameters. What is the depth, and what is the number of estimators, number of boosters that we are using in our classifier. And then we just pass on this weight 2.76. So for every customer who churn, it's just going to have more impact. It's going to have 2.76 times more impact so that our model becomes balanced. There are other techniques too, but this is just one of them. So we are building our XGBoost models. This just takes a little bit more time than logistic regression, just because it's a little more complex and takes a little more time. Actually, it doesn't take too much time, but I don't know why it is. Let's just see. Yes, meanwhile, I've just so once I had ran this, I actually got I basically find out the best parameters to build a model. Okay, it did finally. So now you see here best parameters. So I just use multiple hyperparameters just because I don't have to iterate too many times. So I just give them a couple of hyperparameters and then it just says me what the best parameters are. So here you can see the best max depth was 5, and then where is number of estimators? Okay, number of estimators it says 70. So this is like best parameters which have better accuracy when combine all of these values, permutations or combinations of all these different hyperparameters. And the best score was 0.617. Let's analyze it. So the F1 score for not churn class was 0.84, which is good. For the churn class, 0.61, which is decent. And if you combine it, the F1 score of both of this, it is 0.78, which is not too bad for a basic model. So I just built another XGBoost classifier with the best parameters, which I found it out from here. And then let me just plot it out. I was talking about feature importances. So by plotting this graph, you get to know how each feature contributes to predicting the prediction. So you see that contract month to month, this feature has the highest predictive power. in predicting whether customer is churning or not. The next is total charges, which makes sense. As the charges go high, we saw that the customers were churning more. So similarly, and we saw that gender had minor impact, and the model just agrees to that. It's not very, predictive. So this is just a good way to, check and verify whether it matches to what you have done in the analysis, and you also get an idea of what features you can focus on more to further improve it. So data analysis and processing is like uh, it's there's no fixed way of doing it. Everyone does it in other way. It's data science is more of experimenting things, creating different features than having a perfectly defined way of like if you do this you get this result. It doesn't work that way. You just need to keep experimenting and check whether if it works better. Just as weighted XGBoost, I just have a weighted random forest. So similarly, I just pass it a couple of hyperparameters and then it just returns me with the best. So we are almost done and then we can have questions or discussions. Okay. So here the best score is 0.637. Let's analyze if it did better than XGBoost. So not churn F1 score is 0.85. For churn it is 0.63. Okay, it almost did a little better than XG Boost, but almost similar. So, but it is we got a 0.79 F1 score if we add both churn and not churn, which is not too bad. We just did basic data processing and cleaning. We did not do much of feature engineering. So this was just an intro notebook, so I did not want to make it complicated. So this is a brief about how to build a model, and, and this is done. So the model building is done, and this is the end of the notebook. But if you have any questions about any of the steps like analysis, cleaning, or if you have any doubts understanding precision, recall, you can ask me. So I have shared the link of this notebook. So if you want to try out, there are a lot of data sets on Kaggle. So the ones you can get started with are Titanic, recognizing digit classifier, I guess. Then there is house prediction. So if someone wants to get started with data science, I think Kaggle is very good platform to get started. Collaborate, read others people's work or notebook, how they analyze the data. So it will be like you just get an idea of how to analyze data and you just get started.
I do have a small question.
Hmm.
Where would you recommend like us to start when trying to learn everything from the basics? Like, cause I know we have to use Python for this, and then we have to use like AI stuff.
Yep, correct. So the first thing would be yes, Python, understanding the syntax so that you don't face a lot of difficulties while because everything here is in Python. So you can get started with Python and then you can uh, if you want to go deeper and understand how the algorithm works, then you can definitely go have a look at um, Andrew Ng's Intro to Machine Learning course. It gives a very good idea of how this algorithms actually work, right? So when you are coding or when you're building models, you just import it, but you don't know what's going on inside. So if you want to dive deeper, that's a good thing. Or you can also, learn pandas, numpy, and all these libraries, and you can just get started with working on this kind of problems and then go deeper, like a top-down approach. So you can get started with Python, pandas, learn the basics, and just start doing analyzing or cleaning data and building models. and then you can just dive deeper whenever you want into understanding the math or something like that. So, did I answer your question?
Yeah, that makes sense. Would you recommend that we go really in depth with Python and then go into AI, or just learn the basic syntax and then go into AI?
I would recommend like just learn the basic syntax and then just jump in the water and then you'll learn to swim. So if you start by building a project and then go deeper, the advantage would be like this is my perspective. The advantage would be that you know since you have already built a project, you can relate whatever happening in math to real world context. If you just go into the math and you don't know how it is applied, you just don't like we cannot have a context of how it works or something like that. So I basically follow a top down approach where I just learn the basics to get started, and then as and when I face problems I can just google or learn parallelly.
Okay, got it. Thank you.
Yeah.
Awesome. Does anyone have any other questions for Rishabh? Also, just a heads up, if you haven't already, please fill out the Google form to make sure that you can give us feedback. It would really help to see how we can prepare for next semester. Apart from that, Rishabh, did you have anything else you wanted to add?
No, nothing much. If no one has questions, I think we're good. But if anyone has any issues while running the code or wants any help, we always have a Slack channel, so you can post questions there.
Awesome. Apart from that, we should be good to go to end this. This meeting will be posted on our YouTube channel. You guys are welcome to watch it there and review any material Rishabh covered as well. And apart from that, you guys are all set. Thank you for coming to our last meeting, and we will see you guys next semester.